What we do as a company, which I think a lot of our competition doesn't do, is we give every home that we work in a lifetime labor material warranty. Not just for the workmanship, but for the fact that we are doing an installation that we cannot see. If you do happen to come across something down the road that, hey, that foam wasn't in that wall where it should have been, there was something blocking it, the fiberglass might have got bunched up and it didn't let the foam in and around it, we'll come out there for no cost to the customer and spray foam that completely filled, because you've got a remodel situation where we can actually go there and do it 100% and not have any guesswork. But that's where our lifetime warranty comes in, and that's why we want the customer to know that, everything comes with risk reward. At the end of the day, an injection foam job will get you improved, possibly up to 95% efficiency on that wall. If you can get there versus where you were maybe at 50, it's still worth the effort to put the product in the house. The myth about the R value test is that it's only done at 75 degrees with no air speed changes at all. It's there at zero wind and zero temperature change. So yes, it performs at an R11 at 75 degrees with nothing else occurring around it, but it doesn't perform at that level at 0 degrees with 10-mile-an-hour winds. It'll go almost to zero. The good thing about fiberglass, if there is a good thing, is it's easy to understand. You can go down to Home Depot, you can go to your local big box store and buy as many bags and as many rolls of fiberglass as you want to buy. The inherent problems with fiberglass is actually the selling points we like to make why foam is so much better than that product. Ultimately, fiberglass is what we use for our furnace filters. Fiberglass is what we use for lots of products that actually let air pass through them. And at the end of the day, because fiberglass, whether it's insulation in your wall or furnace filter, is going to let air pass through it, it ultimately reduces its performance level when you get into extreme weather conditions like winter weather or even the hot summer weather we'll experience, pretty much anywhere in the globe. So if you've got a product that lets air pass through it, and as that air passes through it, it reduces the R value performance of that product. Even though you put an R11 fiberglass bat in your wall, that's at 75 degrees with no air pressure differences, no temperature differences. When you actually get a 20-mile-an-hour wind and it's 10 degrees outside, that R value performance of fiberglass goes almost to zero. With a foam product, because it's a solid product, it's an air barrier which doesn't allow any air to pass through it, you don't change performance of that R value of that foam from 75 degrees to 0 degrees or up to 100 degrees. It's going to perform at the same level at any temperature. Mag Insulation began its business in '94 in the insulation business residentially, only doing blown-in blanket fiberglass or fiberglass installations. We weren't believers in cellulose at the time. We didn't even know or even have on our radar at all about spray foam. We were firm believers in it was the best product for the time to put into a house. I still think it's a product that has some inherent value, but once you understand the physics behind why fiberglass performs well or doesn't perform as well versus a foam, you start learning really quickly that though at the time it probably was one of the better solutions, today's technology, it's by far not the best solution. In a wall application, especially in the 70s, 80s, and 90s, before they perfected the wet spray cellulose application in a wall, a lot of people blew cellulose in loose. Well, that loose blown cellulose will get into a wall cavity. The house gets put together, the drywall's done, the house is moving, settling, twisting, doors are slamming. That cellulose would settle from the top of the plate of the wall. It might drop a foot, it might drop 6 inches. But once you've lost that space of insulation, you've basically got a wall that has no insulation in it. Cellulose in an attic, you blow it in loose knowing it's going to settle. Manufacturers actually give you a different thickness for installed thickness versus the settled thickness. Because it settles, it actually improves that performance in an attic because it's higher density, allows less air to pass through it. So you blow in loose 16 inches of cellulose, after 5-6 years of the house, it's probably going to be down to about 12 to 14 inches. But that's not necessarily a bad thing because, like I said, you might lose a little bit of thickness, but you're going to gain a little bit in the fact that it doesn't let as much air pass through it. Where fiberglass, if it's loose blown in an attic, will stay the same thickness throughout its installation. Still going to let a lot of air pass through it. So ultimately in an attic, it's even worse because if it's loose blown, that air is going to rise up through the house at the same level it does now as it did when it was first installed. And ultimately it's letting that heat leave the home by passing through the insulation into your attic. Well, it depends. I always say it depends on if I'm looking at an existing home that's being retrofitted or if I'm talking about a new house or a remodel. New homes, I would tell you by far the best solution to insulate your house is spray foam. By far. It's going to outperform cellulose and fiberglass. I think it's an apples and oranges comparison. I hate to say it, but it's probably a 10-to-1 difference in what I think you'll get out of your home as far as comfort, performance, energy efficiency, being green when it comes to all the things we want to get out of our homes today. I think by far putting spray foam in a new construction is the absolute best thing you can do. Cost, there's always a cost with something that's, I would say, is better, especially on the install side. Typically, depends on the house, but probably 2.5 times the cost of a conventional insulation system is what you'll spend. 2 to 2.5 times more would be a spray foam equivalent. If you have a $5,000 cost on fiberglass to put fiberglass in your house, it'll probably cost you $10,000 to $12,000 to put spray foam in your house. Well, it's ultimately what you're going to get in return for that investment up front. Just on the insulation side of it, you're going to get probably a 4 to 5 year payback on most homes because of your energy savings on that house, just from the beginning day you open that door in that house, from what it would perform if it had fiberglass or cellulose in those walls. We ourselves as a company do a lot of case studies. We like to get the information about what our customers have done, what they ultimately ended up spending on their bills, and put that information together for ourselves, for our own use. But the industry, there's lots of industry sources to show customers that this is done nationwide and worldwide, and these things are proven.